Okay guys, so this is part 2 of the video. What I'm going to do is we're going to finish the exercises at the bottom of the page. We went over some important key points, key vocabulary words in your in the first video. Then I showed you how to graph by hand the first example. And now we're going to do the exercises at the bottom of the page, okay? So I did ask you guys to get a separate sheet of paper. You're going to staple that paper to your watch video notes, and we're going to go on to number 2. Okay, so under the exercises, we have problem number 2. And number 2 says, that f of x is equal to negative 3 times x minus 1 squared. So the easiest thing is to write down what a, h, and k are equal to. In this case, a is equal to negative 3. H is equal to positive 1. Remember, it's always the opposite of what you see here. And k is equal to 0. There is no k in this case. Okay, so I'm going to draw my table of values. And my table of values are going to be changed a little bit based on what I have here. So a equals to negative 3 means it reflects over the x-axis. So instead of opening up, it's now going to be opening down. It's also going to be stretched vertically by a factor of 3. And you're going to shift. This is a plus 1, so we're going to shift to the right 1 unit based on the h. We do not shift up or down because of the k is equal to 0. So if you look at your parent function, you always start with your parent function. Your parent function originally is negative 2, negative 1, 0, 1. Sorry, now I'm going to have to skip a little space. It's 2. The original y values are 4, 1, 0, 1, and 4. Okay, so I take my original graph and I'm going to reflect it over the x-axis, shift it or stretch it vertically by a factor of 3 so it's going to get skinnier than this one, and then I'm going to go to the right 1 unit. So the first thing we're going to do is we're going to add 1 to each of my x values from the parent. Okay, negative 2 plus 1 is negative 1. Negative 1 plus 1 is 0. 0 plus 1 is 1. And 1 plus 1 is 2. 2 plus 1 is 3. On the y-axis, or the y values, I'm going to multiply by a negative 3. So I'm going to multiply each of my y values from the parent function times negative 3. I apologize for it being orange. I don't know why. Okay, 4 times negative 3 is negative 12. 1 times negative 3 is negative 3. 0 times anything is always 0. And then my y values end up repeating. Okay, so you're going to take the x values, which are these, your new x values, and your new y values, and you're going to plot them onto your graph. So when you do that, I'm going to plot each of my points from your table onto your graph. So I went ahead and graphed it already, but you start always at 0. You're going to move to the right one, and you're going to go down 12. But since there's not enough space for us to put 12, I'm going to make each of them equal to 3. So this is actually negative 3, negative 6, negative 9, and then negative 12. So your graph is at negative 1, negative 12, 0, -3, 1, 0, 2, -3, and 1, 2, 3, down, 3, 6, 9, until you hit -12. That's what your graph should look like for number 2. Okay, the next problem is number 3. Just like number 2, we're going to list what A is equal to, which is 2, what H is equal to, it's actually equal to -2, and what K is equal to, which is a +3. We know that if A is positive, it's going to be opening upwards, and that it's also going to be stretched, vertical stretch, by a factor of 2. So it's going to be twice as long, or twice as skinny, twice as narrow. The H is going to shift 2 units to the left, and then the K equals to 3 is going to shift 3 units up. So again, you go back to your original parent function. So your parent function values are always going to be the same, -2, 4, -1, 1, 0, 0, etc. The graph is always going to be the same. It's just that you're transforming, or you're having children, and you're moving the graph up, down, left, right, or reflecting it. So if we look at number 3, I'm going to copy the x values from my original parent function and my original y values from my original parent function. In this case, it's telling me to shift 2 units to the left. So that means I'm going to subtract 2 from each side. I realized I ran out of space, so I went ahead and rewrote it and widened it out. Okay, so I'm going to shift 2 units to the left, which means I'm going to subtract 2 from each of my x values. So -2 minus 2, -1 minus 2, and so on. So what is -2 minus 2? That's going to be a -4. -1 minus 2 gives you a -3. 0 minus 2 is equal to a -2. 1 minus 2 is a -1, and 2 minus 2 is 0. Okay, these are my new x values. With my y values, I'm going to stretch it by a factor of 2. So I'm going to multiply everything by 2. And then after I multiply everything by 2, I'm going to add 3. 4 times 2 is 8, 1 times 2 is 2, 0 times anything is 0, 1 times 2, and 4 times 2. Okay, the last thing is we need to add 3 to each y value to shift it up 3 units, and we're left with 8, 9, 10, 11. 2 plus 3 is 5, 0 plus 3 is 3, 2 plus 3 is 5, and 8 plus 3 is 11. If you notice, the values repeat. So your x values for this function are going to be -4, -3, -2, 1, and 0. And your y values are going to be 11, 5, 3, 5, and 1. 11. So you're going to plot these ordered pairs. You're going to plot these addresses onto your graph. And I already did that. So you always start at 0. You're going to move to the left 1, 2, 3, 4, and go up 11. 2, 4, 6, 8, 10, and then a little bit more is 11. Again, you start at 0, 0, and you're going to plot -3, +5. So you're going to go to the left 1, 2, 3, and up 2, 4, and in the middle would be 5. Again, you start at the origin, 0, 0. You're going to move to the left 2 units, and then you're going to move up 3. So 2, and then in the middle would be 3. And of course, the other side looks exactly the same because that is your axis of symmetry. Okay, just to double check, I want you guys to graph the functions on your calculator. I asked you guys to download Desmos onto your calculator. So this is the Desmos calculator, and it's actually really easy. You're going to graph your first function, or the function we were just working on, which is 2 parentheses x plus 2, close the parentheses, and then this button down here with the a squared gives you the ability to make it squared plus 3. And then you graph your function. So you want to compare this function to our graph. Does it look the same? Pretty close, right? Okay, and then the next thing I want you guys to do is check the table of values. Like, do our table of values match their table of values? And if you notice, our table of values is going to, well, r starts at -4. So what I'm going to do is I'm going to change this one to -4, -3, -2, oops, and then we have -1. So you compare that to our graph, or our table. -4, 11, -3, 5, -2, 3, -1, 5, and 0, 11. Ding, 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 ding. So we got the table correct, and we got our graph correct. This is how you check your answer. This is how you graph by hand, and this is also how you graph on the calculator. Just for kicks, you can graph, whoopsies, the first function, number 2, which was -3 times x minus 1 squared. You click on the a squared, and it graphs your function. I want you to compare the table of values for this function to the table of values we got. Alright guys, so that's your lesson. I'm sorry that it took so long. I'm sorry we had so many mistakes. I don't know how many times I recorded this lesson already. So just want to let you know I love you, and I will see you tomorrow. Your assignment is to finish number 1. So you're going to do number 1 just like we did number 2 and number 3. Draw a table, list A, H, and K, list the transformations, graph it, everything, okay? And I want you to write down any questions that you have in this section down here. Is there anything that was unclear, anything you'd like me to go over again, anything that you were just, I don't know, if you have that question, probably someone else has the same question. Alright guys, that's it for me. I will see you tomorrow. Make sure your notes are written and completed by tomorrow. Thank you. Bye.